Hello everyone, it's Mrs. McWhorter here, and I wanted to take the opportunity to let you all know that I've read your discussions from the first week, and I noticed that a great number of you are really nervous about taking this class because you feel like you're not great at math. So I wanted to take a moment to encourage you and let you know that yes, this is a statistics class, and yes, there will be math, but it's not purely a math class. A lot of the stuff that you'll be learning in this class is theoretical. There's a lot of definitions, a lot of real life applications. So there is a bit of math, but it's not an entirely math course. And also for each chapter, I'm going to be going over any equations that we have for that chapter. So there's not equations in each chapter, but any chapter that we do have equations in, I will be going over them with you. So for chapter 2, we're going to be looking at measures of central tendency. So we're going to be looking at the mean, the median, and the mode. So this is probably one of the easiest chapters, as well as some of the easiest equations that we will be seeing this semester. But nonetheless, I wanted to take the time to go over them with you. So this is the formula for the mean. The x with the x bar is the symbol for the mean that we'll be using this semester. This is the summation sign. And then this x represents each individual score, and n represents the sample size. So in this example that I've provided here, let's pretend that I took a sample of 5 students from my statistics class because I was curious to know what the average age was. So saying I took 5 students from our class, and these are their ages, 19, 21, 20, 23, and 21. In order to find out the mean, or the arithmetic average of the age of students in our class, I would add all of these up, and I would get 104. So adding 19, 21, 20, 23, 21, I would get 104. So that's this part of the equation, where I'm going to sum up all of the individual x's. So these are all of the individual x's. And then I got 5 for my denominator because my sample size is 5, because I have 5 different ages of 5 different students. So I'm going to take that 104 and I'm going to divide it by 5, and I get 20.8. So 20.8 is the mean for this set of scores here. Now the mean is really good for finding averages, the arithmetic average and whatnot. But one of the downfalls of using the mean is that if there are any extreme scores present in a set of data, then the mean is easily skewed. So for example, let's use the same concept here, that I want to find out what the average age for my students is, and I find these 5 students, and these are their 5 ages, 19, 21, 20, 23, and 67. So as you can see, 67 is an outlier. That's an extreme value, what we call an extreme value. And it's called extreme because it's extremely different than the rest of these values. So that's likely going to throw off our mean. So in order to find the mean for this set of scores, we do the same thing that we did up here. We take 19 plus 21 plus 20 plus 23 plus 67, and we get 150. And we're also going to divide by 5 because, again, we have a sample size of 5. And our mean comes out to 30. So as you can see, just one extreme score can completely throw off our mean. So in this first case, I would say the 20.8 is pretty representative of the ages in this sample here. However, I wouldn't say that 30 is very representative of this sample here, because 4 out of 5 of the students are 23 or younger. So to say the average age is 30 is kind of a stretch. So if this were the case and I were a researcher having to make a decision on which one to use, the mean or the median, I would probably use the median, and let's discuss how to find the median. So the median is the midpoint of a set of scores, while the mean is the arithmetic average. So if we take these same values here, 19, 20, 21, 23, and 67, in order to find the median, we are looking for the midpoint. So we have 5 scores, so our midpoint is going to be at the third one right here. And I did forget to mention that when you're looking for the median, you want to arrange the values in order from either lowest to highest or highest to lowest. So I took these values and I decided to go from lowest to highest. So I just simply put them in order. So that way when we get to the middle, that is the midpoint. So in this case, the median would be 21. I'd say that's a lot more representative than 30 to represent the central tendency and the average for this set of students, the average age. Now, what happens when we have, let's say, a set of 6 scores? So I have 19, 20, 21, 22, 23, and 67 for my average, for my students' ages. And I want to know, what is the average age for this set of scores? So what we do then is find the 2 most middle scores. In this case, it's going to be 21 and 22. So I'm going to add 21 plus 22 and then divide by 2. And I have the median of 21.5. So again, it's very representative of this set of scores, I think, even considering that we have an extreme score. So remember again that it's best to use the median when we have extreme scores in our data. And then lastly, to go over the mode is generally going to be categorical data, although sometimes we can use it with numerical data as well. In this example, I'm interested in finding out what is the average political preference for individuals in our class. So we have Democrat, Republican, and Independent. Typically within the social sciences, we have people that are a little bit more liberal, and so we do tend to see more Democrats. So in this case, we have 13 people who identify as Democrats, 2 who identify as Republicans, and 6 who identify as independents. So in this case, the mode would be Democrat. Now notice how I said the mode was Democrat and not 13. So when we're using categorical data, such as these different categories, political affiliation, when you report the mode, you're going to report the category that's most frequent. So I hope this video was informational for you, educational. If you have any questions, please reach out early in the week so that I have time to create another video to answer any questions that you guys may have. And again, for each chapter that we have computational problems for, I will be doing a video for you. So again, good luck on this week's assignment, and I'll see you guys next time.